Hello, and welcome to the Unit 7 review. Let's get started. Okay, number 1 asks us to complete this translation. Given this function, Sm prime square. So what is this telling us? This is telling us to translate the square, the distance of Sm prime, in the direction of Sm prime. So first, let's find out the distance and direction of Sm prime. Now, I'm going to be using the magic of technology. You should probably be using a ruler. So first, I follow the letters in order as they're written from S to M prime. That's the distance. That's the direction. Now, of course, like I said, magic of technology, I'm copy and pasting that same distance, starting at the point that is labeled on my square. Okay. Wherever that line ends, that's where my translated square begins, and I'm going to call it E prime. So we moved the square the same distance in the same direction as Sm prime. For numbers 2 through 4, we want to see whether or not the image shows isometry. So isometry is our image staying exactly the same size and exactly the same shape. So let's take a look. Number 2, yes, that's isometric. Number 3, sure, it's flipped, but still the same size, same shape. Number 4 is a big fat no, that triangle got larger. And 5 is yes, it's just a reflection. All right, for number 6, 7, 8, 9, we're going to reflect. Once again, I'm going to use the magic of technology. I recommend using a ruler or patty paper, whichever way you were taught. Okay, so what I'm going to do is reflect the triangle SZY over the line P. Now, in order to do that, I'm measuring the distance between each point of the triangle and the line P, and then creating the same distance on the other side. So you're using a ruler, I'm using technology. All right, so Z is this far from letter P, and I'm putting that same distance on the other side of the line, and I'm going to call that point Z prime. Next, I'm going to do letter Y. Y is this distance. And I'm going to use that same distance. Oops, let's undo that. There we go. And that becomes Y prime. And lastly, I'm going to measure from, oh, I forgot to undo the thickness of that pencil. I'm going to measure from S to the line P. That's too long. There we go. And I'm going to go ahead and take this measurement and recreate it on the other side. So here is S prime. We got all those measurements. Let's connect our dots, and we have our triangle. So I'm going to connect S to Z to Y and back to S. There's our reflection. Let's do the same thing for number 7. Now, when I do this on paper, what I do is I turn the paper to make the line N face directly straight at me. Right now, I know you don't see me, but as I'm recording this, I'm kind of moving around my tablet. All right, let's do the same thing. We're going to measure the distance and recreate it on the other side. All right, first I'm going to begin with E to N, and I'm going to recreate it over here. This becomes E prime. I'm going to do the same thing with O. And that is O prime. I'm going to do the same thing with a G. Does it have to be in the same order as I'm doing it? No. This becomes G prime. And lastly, what haven't I used? Purple. Let's do R. Okay. Now, might not turn. I don't think mine's going to turn out to be a perfect trapezoid like the original images, but I'm going to get close enough. And if you get close enough, and I see your intention, then hey, we're good. Okay, let's do it. We're going to connect G to E to O to R and back. Hey, that is not bad. I am pleasantly surprised. Let's do the same thing with number 8. I'm going to reflect the parallelogram Mary over G. So we're going to reflect A first, or I'm going to reflect A first and call it A prime, then R. I'm going to redo that line. Didn't look as straight as I wanted it. There we go. Then I'm going to reflect R, call it R prime. I'm going to reflect M, call it M prime. And finally, let's reflect Y and call it Y prime. Wow, that is not a straight line. Let's try that again. I know all of my lines aren't perfect, but that was a little too curvy. That's better. Okay. All right, let's call that Y prime. And let's connect it. M to A to R to Y to M. You know, that's not bad. Let's do number 9 as well. We're going to reflect ANDR over M. Once again, in this case, I'm rotating my paper to make it easier for myself. All right, I'm going to connect D to M. And then on the other side, call it D prime. I'm going to do the same thing to N. And to R. And lastly to A. Now, if you're ever curious on how do I connect these letters, what order, follow the order given in the original problem in the transformation right there. Okay, so let's go from A to N to D to R to A. You know, that did not turn out as beautiful. Oh, gosh, that looks like a kite more than a diamond. But you know what? I did try my best, and that's what counts, right? That's fine. If yours turns out like this, and I can clearly see your work, then we're good to go. All right? No, I don't expect you to be much better artists than me, although it would be nice if when I see some beautiful artwork on the test. All right, number 10. Which diagram shows the rotation RC 90 ABCD? And it equals A prime, B prime, C prime, D prime. What that means is we're going to rotate counterclockwise 90 degrees. And I know it's counterclockwise because the 90 is positive. Counterclockwise, imagine a clock. Counterclockwise is going backwards on the clock. So what I'm going to do is I'm just going to look at both of the new A's and see if any of them follow the right direction. Okay, in letter A, I'm going to connect A to C to A prime. It looks like it's going this way, which is clockwise, so no. For letter C, if I go from A to C to get to A prime, that's a straight line. And just to double check, if it's B or no diagram, we're going to connect A to C, then back to A. It does look like it's going counterclockwise. Letter B is the right answer. For 11 and 12, we're going to complete each rotation. Number 11 asks us to go negative 90, so clockwise. All right, so this is how we're going to do it. You connect R to X and then form a perfect 90-degree angle. Well, as perfect as humanly possible. And then we're going to go from S to X and perform the same thing by doing a perfect 90-degree angle. And here's our new line, R prime, S prime. Let's see how it looks like if I erase all that. There we go, 90-degree rotation, clockwise. Number 12 is 90 counterclockwise, because that's a positive 90. So I'm going to connect X to C. And counterclockwise means we're opening this way, so I'm going to open like this. X prime, 90 degrees. Next, I'm going to do the same thing to Y. I connected to letter C. Again, I want it to go counterclockwise. So, oh no, that doesn't look like 90. There we go. 90 degrees for Y prime. And then we connect the two. Let's see how it looks like without the lines. Yeah, perfect. Rotated counterclockwise. All right, number 13, circle the figures with no lines of symmetry. I can see some lines of symmetry in the first, the second, not in the puzzle piece. Triangle, I see one, not the car. I do see one in B. Can't do the cup. This is a 5-sided figure. That's fine. And then this weird shape doesn't have any lines of symmetry. Speaking of lines of symmetry, let's draw them for a triangle, hexagon, and heptagon. Okay, so triangle. Let's begin. Let's see. So imagine these are straight lines. I was able to make them straight on the answer key that I provide you guys on my Teams page. But it took some time and effort to make them that way. So hopefully you have a ruler out that's handy that you could do this with. Okay, so for triangle, first line of symmetry I see is through this point. Then I see another line of symmetry, another way that I could split it in perfect halves right here, and then right there. So that means 3 lines of symmetry for the triangle. So 3-sided figure, 3 lines. Now let's look at a hexagon. A hexagon has 6 sides. Let's see if it has 6 lines. All right, let's go. The first one I see is from this tip down to here. Cool. All right. Then I see another one here. All right. And another one here. That's just 3. However, I can also split it right here down the middle, which means I could also split it. Oh no, I'm out of colors. Means I could split it down the middle here. And one more. What color do I want? Let's do yellow. Split it here. Okay, so that is 6 colors, 6 sides, 6 lines. So yeah, you can definitely assume that the amount of sides a figure has is going to be the amount of lines of symmetry it has. All right, let's take a look now at a heptagon. A heptagon has 7 sides. Let's see if it has 7 lines. All right, let's go. 1 line, 2, 3, 4. That's an ugly line. Let's try that one more time. 4, okay. And let's change some colors. 5. And let's do this blue. 6. And then one more. Let's do gray. 7. All right, beautiful. 7 sides, 7 lines of symmetry. Fantastic. Okay. Onwards we go. Number 15. Which sequence shows how we get from the image to the pre-image? Or from the pre-image to the image. I don't know why I said that backwards. All right, in this number 15, the pre-image is this one right here, and our image is that one because of the primes. So I wanted to zoom in and make sure. All right. First it says a reflection across FG and then a rotation 180. Well, let's see. If I reflected and then rotated clockwise, no, that doesn't work. All right, letter B, rotate 90 degrees about H and then translate to the right and down. So 90 degrees about H would be something like this. And then to the right and down. Hey, that sounds right. Okay. Let's check C and D just in case. Translate left and up. Absolutely not. Rotate and reflect. No, that doesn't work either. Okay, B is our answer. Perfect. Let's move on to 16. So our image is this guy Pre-image is that one. Image is this green one up top because that one has the primes. Okay. Reflect across NM and then rotate 180. Okay, so if we reflected and then rotated, no, it would not end up there. That doesn't work out. Okay, translate left and up. Left and up, absolutely not. 90 about M, negative 90. So that clockwise about M and then up and left. Let's see. So 90 about M would bring us up here, up and left. Hey, that sounds right. Just in case, let's try D, 90 clockwise. You say counterclockwise. And then translate up, and then reflect against over NK. No. It sounds like D is the right answer. Okay. And I was just drawing a arrow to double check that C is right. Yeah, rotate 90 clockwise. Perfect. Yes, yes, yes. All right, number 17. The purple L on the left is our pre-image, and then the green one is our image. Okay, the first one says reflect across UT and then rotate 180. No. Translate to the left and down. Absolutely not. Rotate 90 degrees about S. That would still be like on this side, so no. I'm pretty sure it's letter D, but let's read it to make sure. Rotate negative 90 about S. Okay. Then translate to the right and up. Is that it? Wait a minute. Is it C? Rotate negative, so positive 90 would be clockwise. And then reflect across UT. No, I think it should be letter D because it's up and to the right. Okay. All right, let's continue. Number 18. Draw and describe the sequence of isometries that shows the two figures are congruent. All right. Well, one thing I do see is a rotation clockwise. You may also see it as a reflection. Both of those are valid answers. Letter C, to me, looks like just a rotation clockwise. And if you wanted to, you could also add in translation to the right. And lastly, we've got number 20. Here, well, I think there's only one transformation here, and that is a translation to the right. Okay, that's about it. If you have any questions, please feel free to ask myself or your teachers. Otherwise, have a wonderful rest of whatever day it is for you. Bye!